Welcome back. Since this is our slackers that don't show up. We're going to take a look at section 11.3 today. Remember in chapter 11, we were doing two populations or two samples. And we've already done a proportion test and a paired test. This is an unpaired beans test. So StatCrunch listed as under StatCrunch, you'll see for T-stats, Q sample, you'll see a sample. It's listed as one sample, two samples, and paired. We did one sample back in chapter 10. We did paired. This was 11.2. This was chapter 10. 10 point something, 3, I think. The two sample ones is today. It's 11.3. It doesn't say unpaired, but it is. So it has the same requirements. Well, it's very close to the same requirements as the paired one. We want N1 to be greater than or equal to 30, N2 to be greater than or equal to 30. We want N1 to be less than 5% of big N1 and N2 to be less than 5% of big N2. We want simple random sampling. And we want independent samples. This top part can be waived if the population is stated to be normally distributed. If that's the case, we can ignore this part. Ideally you don't. 30 isn't a lot of people to ask for two different groups. Where the paired sampling required them to come in pairs and thus N1 had to equal N2. In this one, N1 does not have to equal N2. But it can. So don't assume N1 equaling N2 is a paired setup. Ready for the next page? All right. So in StatCrunch, we will go stats, T-stats, to sample. You either have with data or with summary. With data, it's pretty straightforward. You gotta have everyone's answer. With the summary one, you need the sample means, which is X1 bar and X2 bar. And you need the sample standard deviation, S1 and S2. If you don't have the data, they should be providing. In fact, if you see something that gives you two sets of means and two sets of standard deviations, there's a good reason to believe that it's this type of test right here, like when we're doing the final. And of course, you need to know sample size. So you'll need N1 and N1 and N2. There is an option that we will ignore. Leave the optional pool variances checked. Checked. We use this. This is when you think both groups have the same variance. When both groups should have the same variance. But very rarely is there any reason to assume that's the case. Ooh. I gotta get up my favorite hypothesis test ever. So this is our first example. This is a true event. Professor Jones. That's me, FYI. El Jefe. Believed that, or believes that spending 1 week discussing study skills, time management, growth mindset, shit like that at the beginning of class. Of each semester. Raises overall grades. So it's kind of impossible to do it with the same group of students. But what I did is in fall of 2018, I did not have it, didn't do it. In spring of 2019, I implemented this strategy. For intermediate algebra. A class we don't even offer here anymore because the blessed state of California thinks it knows how to teach math better than math teachers know how to teach math. You gotta love people that think they're experts in shit they don't know anything about. I have the results in StackCrunch already. I have the data stored in StackCrunch. Data is in StackCrunch. Test Professor Jones's claim. Go take a look at it. You guys ready? I had 36 students in one class and 48 in the other. This is their final overall grade, not their grades on their final exams, the overall final grade. So I'm going to do stats. Wow. We need to set up, figure out H0 first. I'm going too quick. So we need to come up with H0 and HA. H0 is always going to be the same. It's always going to be mu1 minus mu2 equals 0. I don't remember if they use mu d or not here. They might. If they do, that's mu1 minus mu2. One of them has it. I think paired has it and this one doesn't. The question is, what am I going to say for HA? I'm saying that it's greater than. So what can I expect from the results I did earlier would support what I'm saying? If my spring grades were higher than my fall grades, that means my strategy worked. Does that make sense?
Yes.
All right, let's write that down. Spring being great, spring grades greater than fall grades means that I had higher test score or higher average score, which means if I subtract that over, if I do spring minus fall is greater than 0, that helps me pick my mu1 and mu2. I will make group 1 spring and group 2 fall. Ready? I've got them in there. Spring is my first column, fall is my second. So spring, T-stats, 2 sample with data. I've got values for spring, or my group 1 is sample 1. And my group 2 was fall is sample 2. And I want greater than 0. There's that pool variances that I said leave alone. Leave that unchecked. Don't bother with it. So I get my T-stat. I can see is 2.013. P-value is 0.0237. And it tells me what the sample difference is. 10 points. Grades were higher in spring over fall by 10 points. A full letter, the average grade. The average grade was a full letter grade higher. Which is why that p-value is so low. In fact, the p-value is so low that it's lower than alpha. Since the p-value is too low, we reject the HO and we support HA. HA wasn't that spring grades were better than fall grades. It was that the stuff on time management stuff. There is sufficient evidence to support the claim, support Professor Hefe's claim, Jones's claim. Study skills and other soft skills for a week. Raise the average grade. I kind of want to do this experiment again, but it's kind of like during the same semester. It's kind of hard to pick 2 classes that are like identical. I can't do night versus day because there's a completely different makeup of students night versus day. And I tend to not have 2 daytime classes for the same subject. And now that I'm very confident that it works, I feel guilty as fuck for not doing it for one of the classes when I believe it does work, you know? It's kind of like some immoral shit right there. That's how it works. I got 2 more examples for you. Any questions? Is this process looking familiar? Have you guys been doing your homework?
I have stuff like, why is hypothesis testing so hard?
All right, what's the hard part of it?
Like, I don't know, I'm stuck on like question 16 or 17.
Do the Ask My Instructor and it'll send me a link with your numbers. And it might there's a couple problems in there that I've missed that are worded poorly and I haven't taken out. A couple students have emailed me and I know I'm gonna like gloss over them and just give everybody credit for it later, but I didn't do an announcement. But if you come across something that's just not making sense, do ask my instructor. I will respond to it. If you do it, hit me on Friday night, it might be Sunday morning before I see it. But sometimes I check it on Saturdays. But I will check it and get back to you.
Yeah, I spent like 6 hours on chapter 10.
Oh, hell, God.
Embarrassing.
Well, chapter 10 is when you really first start doing this stuff. It does get easier. It should take you less time to do chapter 11. Because what you're really learning right now is these steps.
Yeah.
And most of the steps don't change.
And
That's a good
the
part.
wording that throws me off, and then like the different steps you have to do, like when it switches from just like the simple random sample, and then it gives you like, you have to do the standard deviation. And something else I haven't written.
Okay. One of them in there had bad shit. I know it. All right, let's look at an example. Let me go back over to PC. This is a fun test that students did. Not the state quarters. A group of students wanted to test the strength of Bounty paper towels versus generic ones like Kirkland. Then you get a Costco brand. So what they did is they wetted each paper towel with the exact same amount of water. They like measured it each time, got it wet, so it was a little damp. And then they put it tight between two like surfaces being held down by books and started stacking pennies on that shit. And they, after it broke, they counted how many pennies it took to break the paper towel. That kind of gives you an idea of how strong it is. Some of them held a lot of fucking pennies. In fact, a lot of fucking pennies. This is the list of the Bounty and the Kirkland results. If you look at Bounty, there's a lot in the 500 range, a couple in the 700, a few 400. Kirkland, I see stuff 6, 7, 8, 900, 900 pennies. Picture a roll of pennies, and now picture 18 fucking rolls of pennies. I don't know that this is true. I think that they fucking bullshit on this, because that's a lot of 18 rolls of pennies is heavy. Like, you don't want to hold 18 rolls of head. You like need a bag for that shit. First off, it wouldn't fit in your hand, but even if you had big old like mitts, it's still a lot of weight. Like pennies are heavy. Not one penny, but 900 pennies. That's a lot of pennies. So they might have done it. All this we have to assume they did. This is the results they got. We want to test the claim that Kirkland paper towels are stronger than Bounty paper towels at the 0.01 level of significance. Okay. So when you have problems like this, and you will, like in StatCrunch or in the homework, they'll give you a data set. The first thing we got to do is, well, I'm going to write down some information over here real quick. So this is the Kirkland versus Bounty. Paper towels. And we want to test that Kirkland is stronger than Bounty. We're going to use 0.01 level of significance. These lecture notes are actually available in Canvas in the file section. If you ever wanted to look at them and like redo this stuff on your own. So they have a data set. We're going to use the data, stats, T-stats to sample with data. The way they tested it was by supporting pennies. So Kirkland being stronger than Bounty means Kirkland held more pennies than Bounty. That's what their claim is. Kirkland holds more pennies. Or average pennies, I'll say. Which means Kirkland results should be greater than the Bounty results. If I make this my group 1 and this my group 2, then I have N1 minus N2 is greater than 0. That'll be HA. Nope. What the fuck am I doing? mu1 and mu2 is greater than 0. H0 will be that they're equal. H0 always has the equal sign. You guys ready? Copy it. Come over here and paste it. Do a little management, get rid of the words on list. We don't want that in there. All right. Stats, T-stats, to sample with data. And we're saying Bounty was greater than, or Kirkland was greater than Bounty. Bounty, Kirkland greater than Bounty, check. And I'm getting a T-stat of over 8, holy crap. .02. I get a p-value of less than 0.0001. That's what I have there. I'm comparing it to alpha. Alpha is not 0.05 anymore. It's 0.01.
Is that an 8.02?
Yeah.
So when we're doing the p-value, we have to enter, if it has that greater, we have to enter it.
I put that's less than, but you should.
Yeah.
It means it's even lower than that. But that's usually, at this point, they're going, you're not testing lower than this, so we stop showing you lower than this.
So but I'm saying when it says what's the p-value, we have to enter the.
You can put equal if you'd like. It doesn't change this part right here, is that this is lower than that. And since that is lower than that, we are too low. We reject H0, we support HA. HA was Kirkland is stronger than Bounty. There is sufficient evidence to support the claim that Kirkland paper towels are stronger than Bounty. And since I don't have the average or the regular alpha, I'm probably going to add in at the 0.01 level of significance. Because that's even more strict than the 0.05. It takes more evidence to support that than it does 0.05. Any questions? That's pretty much all there is on 1.3. You can fuck out if you like, or you can stay and work. That's all for today, folks.
Congratulations.